The question is, the input to the system is x of n equal to 2 del of n plus 2 plus 2 del of n minus 2. And the frequency response of the system is 4 minus 2 into e power minus 2j omega. Then what is the value of y of n at n equal to minus 1? Okay, right. See, we know that y of e power j omega is equals to x of e power j omega into h of e power j omega. Then what is x of e power j omega? It is the dtft of this one. So 2 e power 2j omega plus 2 e power minus 2j omega. Now y of e power j omega is equals to, it is a multiplication of x of e power j omega and h of e power j omega. So x of e power j omega is 2 into e power 2j omega plus e power minus 2j omega into 4 minus 2 into e power minus 2j omega. If you multiply these two, we are going to get the final value is 8 e power 2j omega minus 4 plus 8 e power minus 2j omega minus 4 e power minus 4j omega. Now if I take the IDTFT of the given signal, then y of n is equals to 8 del of n plus 2 minus 4 del of n plus 8 del of n minus 2 minus 4 del of n minus 4. Now the question is, what is the value of y of n at n equal to minus 1? At n equal to minus 1, no impulse signal is there. So the answer is y of minus 1 is equals to 0. So the answer is 0. Okay, the question is, this is the plot given. What is the expression for the given plot? Okay, if you observe the options, there are two signals are appearing, u of n plus 2 and u of minus n plus 3. First try to draw that signal. So u of n plus 2, n, u of n plus 2. n plus 2 is minus 2, minus 1, 0, 1, 2, 3, 4 up to so on infinity. So like this, up to so on. Amplitude is 1. This is u of n plus 2. Next is u of minus n plus 3. u of minus n plus 3 is extending from minus infinity to 3. So up to so on, minus 2, minus 1, 0, 1, 2, 3, 4, sorry, up to 3, minus infinity to 3. Minus 2, minus 1, 0, 1, 2, 3. This amplitude is 1. So once you observe these two plots, the given signal is extending from minus 2 to 3. When it is possible, only in the case of multiplication is possible. So the resultant signal is now x of n is equals to u of n plus 2 into u of minus n plus 3. See, if I multiply these two signals up to minus 2, this signal amplitude is 0. So 0 into something, you are going to get 0. So no signal before 0. From minus 2 to 3 onwards, both are maintaining 1, 1 into 1, 1. So next, after 3, this is 0, 0 into something, 0. So to get this signal, the required operation is multiplication of these two plots, u of n plus 2 into u of minus n plus 3. So the right answer is C. this is the input-output relationship of the system is given, and the system is asking that is it causal stable, causal unstable, non-causal stable, non-causal unstable. So how to verify this? Let us see now. So first, causal. Once you observe here, y of n is depending upon x of k. K's limits are minus infinity to n plus 3. So n is depending upon n plus 3 means n plus 3 is a future value. So present output is depending on future input. Future input. So it is a non-causal system. It is a non-causal system. Next, see the stability of the system. Let us apply a bounded input to the signal. Let us I am applying x of n is equals to u of n. It is a bounded input. Now observe what is the output. Y of n is equals to sigma k is equals to minus infinity to n plus 3 u of k. So u of k, you know the definition, 1 for k greater than or equal to 0. So sigma k is equals to 0 to n plus 3 1. This is possible only when n plus 3 is greater than or equal to 0. So now if you solve this summation, you are going to get for n plus, for upper limit minus lower limit plus 1, n plus 3 minus 0 plus 1 is n plus 4. This is for n greater than or equals to minus 3. So this is existing for n greater than or equals to minus 3. So I can write this as n plus 4 into u of n plus 3. U of n plus 3. So this is output for the given signal. So once you observe that this output as n tending to infinity, as n tending to infinity, y of n tends to infinity. No, so it becomes a unstable. So for a stable signal, I am going to bounded signal, I am going to get bounded output. So the given system is a unstable system. So the given system is non-causal and so the given system is a unstable system. So the given system is non-causal and unstable system. So the right answer is D is the right answer. What is the Laplace transform of the given signal? So if you apply Laplace transform to both sides, the ROC of this signal is ROC is equals to first signal ROC is sigma greater than or equals to minus A intersection sigma less than or equal to minus B. So the condition given is A less than B. If A is less than B, the common ROC is no common ROC. If no common ROC, then no Laplace transform for the signal. So the answer is D is the answer. The question is, this is the equation given, y of n minus y of n minus 1 minus 2 y of n minus 2 equal to u of n, and given that y of minus 1 is 0, y of minus 2 is 0, then compute y of 3. We'll see now. So first substitute n is equals to 0 in the given equation, n equal to 0, then y of 0 minus y of minus 1 minus 2 y of minus 2 is equals to u of 0. You know what is the value of u of 0? U of n is 1 for n greater than or equal to 0. So u of 0 is 1. Y of minus 2, y of minus 1, 0. So finally y of 0 is equals to 1. Next, let us substitute n equal to 1. Y of 1 minus y of 0 minus 2y of minus 1 is equals to u of 1. We know that given that y of minus 1 is 0, y of 0 is 1. So y of 1 minus 1 is equals to u of 1 is also 1. So y of 1 is equals to 2. Next, substitute n equal to 2. Then y of 2 minus y of 1 minus 2y of 0 is equals to u of 2. Y of 2 minus y of 1 is how much? 2. Minus y of 0 is 1. 1 into 2, 2 is equals to 1. So y of 2 is equals to 5. Next, substitute n equal to 3. Then y of 3 minus y of 2 minus 2 into y of 1 is equals to u of 3. So y of 3 minus 5 minus 2 into y of 1 is 4 is equals to 1. So y of 3 is equals to 10. So the right answer is 10 is the right answer. The question is, this is a given signal x of t and asking that what is the value of angle of x of j omega and x of j0. Okay, let us assume that y of t is equals to x of t minus 1. You observe that if the signal x of t signal shifted to the right side by 1 unit, it is extending from minus 2 to 2. So now the signal becomes, y of t signal becomes, it is a real and even signal. So for a real and even signal, the angle of y of e power j omega is equals to 0 because y of t becomes real and even. For a real and even signal, the angle is 0. So now if you apply Fourier transform to above equation, y of j omega is equals to e power minus j omega into x of j omega. If you apply angle on both sides, then angle of y of e power j omega is equals to angle of this one plus angle of x of e power j omega. Angle of this one is 0 is equals to angle of this one is minus omega plus angle of x of e power j omega. Now the angle of this is x of j omega. Sorry. Now angle of x of j omega is equals to omega. So the angle is omega. Next, we have to find out x of j0 value also. So we know the Fourier transform is x of j omega is equals to minus infinity to plus infinity x of t e power minus j omega t dt. Now x of j0 is equals to minus infinity to plus infinity x of t dt. What is the meaning of this equation is area under the signal x of t. If you calculate the area under the signal x of t, you are going to get 5. So the angle is omega and the area under the signal is 5. So the right answer is B. The question is, this is a signal given x of n equal to mod n for minus 3 to plus 3, 0 otherwise, and it is the input output relationship between the system, and what is the value of y of 3. Once you observe this, what is the meaning of this system is, it is basically an accumulator. This computes the running sum of all the past input values up to the present time. Okay, so the response of the system is, first let us see what is x of n signal. X of n is equal, so if you calculate up so on, if you substitute minus 3, 3, 2, 1, 0, 1, 2, 3, 0 up to so on. Okay, this is the given signal now. So this is a 0th time index. Now this is 0, minus 1, minus 2, minus 3. If I substitute n equal to minus 3, what is the value it is going to give? Minus infinity to minus 3, we have to add all the values of x of k. Only this signal is existing, remaining all are 0. So 0 plus 0 up to so on plus 3 is 3. So at minus 3 you are going to get 3. So if I substitute minus 2, minus infinity to minus 2, minus 3 is existing, minus 2 is existing. So 3 plus 2 is 5. Like that, add all the values, then y of n you are going to get is up to so on 3 comma 5 comma 6 comma 6 comma 7 comma 9 comma 12 comma 0 comma up to so on, 12 comma up to so on. So now the question is, what is the value of y of 3? So this is the 0th time index. This is 1, this is 2, this is 3. So now y of 3 is equals to 12. This is a right answer. The question is, this is a signal given and what is the value of this? Okay, so first x of t is equals to, it is like 2 sin a cos b. So I can write this as sin of a plus b, sin of a plus b into t plus sin of a minus b into t into u of t. Let us apply Laplace transform on both sides. X of s is equals to 1 by 2 into a plus b by s square plus a plus b whole square plus a minus b by s square plus a minus b whole square. So we know the Laplace transform formula, minus infinity to plus infinity x of t e power minus st dt. So let us substitute in place of s0. So minus infinity to plus infinity x of t dt. So this value is nothing but capital X of 0. Let us substitute s is equals to 0 in this equation. Now x of 0 is equals to 1 by 2 into, if I substitute s is equals to 0, then a plus b by a plus b whole square, it becomes 1 by a plus b plus 1 by a minus b. This is equals to 1 by 2 into 2a by a square minus b square. So x of 0 is equals to a by a square minus b square. So the right answer is C. The Fourier transform of x of t is equals to e power minus a square t square is, this is given. Then what is the value of beta by alpha? We know the standard pair e power minus pt square Fourier transform is square root of pi by p into e power minus omega square by 4a. In terms of f, if I write that square root of pi by p into e power minus pi square f square by a. Sorry, this is p. Okay, now Let us substitute p is equals to a square. Then e power minus a square t square is square root of pi by a square into e power minus pi square f square by a square. So this is equals to square root of pi by a into e power minus pi square f square by a square. But once you compare with the original one, then alpha is equals to a and beta is equals to a square. Then beta by alpha is equals to a. So the right answer is a is the right answer. The question is, this is a signal given phi sync phi t is sampled at 10 hertz using ideal sampler, and it is passed through an ideal low pass filter of cutoff frequency 5 hertz. Then what is the output spectrum of the filter? Okay, right. First, let us find what is a sampled signal spectrum. Okay, so x of t is equals to 5 sync phi t can be written as sin 5 pi t by 5 pi t. So this is equals to sin 5 pi t by pi t. So what is the Fourier transform of this one is f capital X of f. So the Fourier transform is minus 2.52 plus 2.5, this is okay 1. Sin at by pi t, it is like okay rectangular of omega by 2a. So the omega is 5 pi, okay, a is 5 pi. So if we take in the f domain minus 2.52 plus 2.5, this is capital X of f. Now this signal is sampled at sampling frequency of 10 hertz. What is a sampled signal spectrum? X del of f is equals to 1 by Ts sigma n is equals to minus infinity to plus infinity x of f minus nfs. But fs is given as 10. Let us substitute that. So 1 by Ts is also becomes fs. So 10 into sigma n equal to minus infinity to plus infinity x of f minus 10n. Let us expand the signal. Then x del of f is equals to 10 into up to so on plus capital X of f plus 10 plus capital X of f plus capital X of f minus 10 plus up to so on. Let us try to draw the signal. So f x del of f. See what is x of f plus 10? F plus 10 is nothing but the signal is shifted to the left side by minus 10 units. So the resultant signal is minus 12.5 and this is minus 7.5 and amplitude is multiplied with 10. Next, x of f. X of f is minus 2.52 plus 2.5, 10. Next, x of f minus 10. F minus 10 is nothing but it is 7.5 to 12.5, amplitude is 10, up to so on. This is a sampled signal spectrum. It is passed through a ideal low pass filter of cutoff frequency 5 hertz. So means that filter is allows the signal only which are less than 5 hertz. So only this part is allowed, remaining part is not allowed. So what is the output spectrum of the filter is y of f is similar minus 2.52 plus 2.5 with an amplitude of 10. So y of f is equals to, I can write this as 10 rectangular of f by 5. This is the answer. Answer is A. determine the time signal corresponding to the magnitude and phase spectra given with omega naught equal to 2 pi. So this is the magnitude spectrum of exponential Fourier series coefficient. This is the phase spectrum of exponential Fourier series coefficient. From these two, let us find Cn. Cn is equals to mod Cn e to the power of j and angle of Cn. Once you observe that n is existing at -4, -3, -2, -1, 0, 1, 2, 3, 4. Okay, let us substitute. C minus 3 is C first minus 4. C minus 4 is equals to mod C minus 4 e power j and angle of C minus 4. Mod C for C minus 4 value is how much? 4. What is the angle of C minus 4? Minus pi by 4. E power minus j minus pi by 4. Next, similarly C minus 3 is, what is the magnitude? 2. What is the phase? Plus pi by 4. 2 e power j pi by 4. What is C minus 2? This is magnitude is 0. 0 into anything is 0. So C minus 2 0, C minus 1 0, C 0 0, C 1 0, C 2 0. Next C3 is exist. C3 is equals to 2 e power minus j pi by 4. Similarly C4 is equals to 4 e power j pi by 4. Remaining all are 0. So these are the exponential Fourier series coefficients. Now asking that what is the time signal corresponding to this exponential Fourier series coefficient. So we know that the exponential Fourier series expansion is sigma n equal to minus infinity to plus infinity Cn e power jn omega naught t. Omega naught given in the problem is 2 pi. So x of t is equals to sigma n equal to minus infinity to plus infinity Cn e to the power of j 2 pi n t. So now n is varying from minus infinity to plus infinity, but what are the values are exist? Minus 4, minus 3, minus 2 not exist. So 3 and 4 values are exist. Let us substitute these values. Then x of t is equals to, first to minus 4. 4 e power minus j pi by 4 into, if I substitute n is equals to minus 4 in this equation, it becomes minus j 8 pi t. Next, plus 2 e power j pi by 4 e to the power of minus j 6 pi t plus 2 e to the power of minus j pi by 4 e to the power of j 6 pi t plus 4 e to the power of j pi by 4 e to the power of j 8 pi t. So these are the signals. Now simplify this. Let us take this common, this in this common, in this common, in this common, and simplify this. You are going to get x of t is equals to finally 8 cos of 8 pi t plus pi by 4 plus 4 cos of 6 pi t minus pi by 4. So the right answer is B is the right answer. This is the Z transform of x of n is given, and the corresponding ROC is this one, mod A less than mod Z less than mod B, and asking that what is the value of x of 0. So from the given ROC, mod z greater than mod a means what is the inverse z transform? This is equals to 1 by 2 a power n u of n, and mod z less than mod b means 1 by 3 b power n u of minus n minus 1. Now substitute in place of n 0, x of 0 is equals to 1 by 2 a power 0 u of 0 minus 1 by 3 b power 0 u of minus 1. You know that u of minus 1 is 0, u of 0 is 1. So finally you are going to get x of 0 is equals to 1 by 2. The answer is C. The question is, what are the discrete Fourier series coefficients of the given signal x of n? Okay. So discrete Fourier series exists for this signal if and only if omega naught by 2 pi must be a rational number. So what is the omega naught value here? Root 2 into pi. So what is omega naught by 2 pi? That is equals to root 2 pi by 2 pi. That is equals to 1 by root 2. It is not a rational number. So the given signal is non-periodic signal. So for non-periodic signals, Fourier series is not exist. So what is the right answer in the given option C is it cannot be expanded by using Fourier series. So the right answer is D.